Have you ever wondered how meteorologists are able to predict the weather? Well, they need to know a lot of parameters such as temperature, pressure, humidity. These are all pretty simple to measure, but one thing that's not so simple is wind velocity. The wind velocity can be thought of as a vector field on the Earth's surface, where at each point there's a vector that corresponds to the wind velocity at that point. For example, here it would mean the wind is blowing in this direction with this magnitude. Now, how do you measure something like this from a single place? You obviously can't be standing here measuring the wind here, measuring the wind here all at the same time. There needs to be a way to measure the wind at all these points, the wind velocity at all these points all at the same time. To do that, we make use of something called the Doppler effect. If you've ever been standing on the side of the road as a car has been honking its horn, you would know that it sounds like eeeew. So the higher pitch noise corresponds to a high frequency, and the low pitch noise corresponds to a low frequency. But why does that happen? Sound waves are just compressed and rarefracted sections of air. If this car is moving this way and it's honking its horn, it is emitting sound waves, and because it is moving, the waves are getting compressed near the front and rarefracted near the back. Now, if you measure the wavelength here, it's a lot shorter than the wavelength here. So the shorter wavelength corresponds to higher frequency, and longer wavelength corresponds to lower frequency. Now, if you have a raindrop moving in the atmosphere, and you send a microwave signal of a known frequency to it, it'll hit the raindrop, and the raindrop will reflect a higher frequency microwave back, which you can detect. So this is called the Doppler effect. Now, in order to be able to apply this to every raindrop, you have a giant radar on a tower usually it's spherical, and it sends out these microwaves to all directions. So now a water droplet here that is moving, let's say it's moving that way, the reflected wave is going to come back even longer frequency, with an even longer wavelength. So you know by the lower frequency that it's moving away from you. Conversely, if the raindrop is moving towards you, it'll reflect a wave that is of higher frequency. So you know that it is moving towards you. Now, meteorologists are able to use this phenomena to create these wind velocity maps. So if there's an area of rotation like this, which can be seen by measuring the wind velocity at all points in this area. Now, in this area, even though it's pretty chaotic, you could still see that there is a rotational area right here. Now, something like this would correspond to a rotating air column, which is a potential tornado threat. So, using Doppler radar systems, meteorologists are able to predict the weather, as well as dangerous weather events such as tornadoes.